Hello, good evening, engineers, especially to you, Engineer Tagoba. I am Daryl Jake Borinaga, and here is my presentation about my topic. So, I'll be discussing about the modification of activated sludge process. Pero bago tayo go deeper into my topic, let's have first a recap about what was discussed before. So, before we move on to this modification, para na rin mag-guide tayo kung saan na tayo sa ating discussion. Okay? So, now, we are already in the secondary treatment in which ang purpose ito ay nagre-remove ng organic materials sa ating wastewater by biological means. Now, why do we need to remove organic materials? Especially this what we call as BOD. Dahil ang BOD ay isang indicator sa level of wastewater pollution. Kumbaga, ito ay measure sa strength ng ating wastewater effluent na kapag ating i-release na sa surface water, kung high BOD content ang ating treated effluent, ay maaaring magdudulot ng fish kill kasi ang BOD ay nag-deplete ng oxygen. So how is this removed? In secondary treatment, there are two ways on how to remove these BOD, and it depends on how we brought in contact with the microorganisms, in which these microorganisms feed on these organic matters or the waste that produces the BOD in the wastewater. So we have the suspended growth reactor and the attached growth reactors. Na hindi na tayo mag-go deeper into these two, basta ang topic natin ay ngayon ay about ASP, in which ito ay isang uri ng suspended growth reactor. Okay? Ang ASP kasi is the widely used na kung saan ang ginagawa dito ay nag-i-aerate ng wastewater or nag-i-introduce ng oxygen para tutulong sa paglaki ng mga microorganisms na nasa wastewater. Now, ang ASP ay isang suspended growth reactor, yun na nga, at ito ay nadiskubre ni Gilbert Fowler na kung saan isang araw pumunta siya sa isang laboratory sa Massachusetts sa USA at nakita niya na may mga ginawang experiment about sludge process. Tapos pag-uwi niya sa England ay ikinuwento niya ito sa kanyang mga estudyante na sila Arden at Lackett at further develop nila and ika nga ni Sir sa last presentation, the rest is history. Now let's ask, why do we modify? Of course, first of all, we want to improvise or enhance the system. In this case, in our aeration tank, we want to increase the organic loading, the supply of the oxygen. We provide additional nutrients required for the proper treatment and many more. So for us to have a more efficient ASP, we modify, and these are the modifications of ASP. You have step feed aeration, the tapered aeration, extended aeration, complete mix, contact stabilization, and pure oxygen systems. But for my topic, let's focus on the step feed aeration and the tapered aeration. So first, let's have the step feed aeration. Now there are studies that say it was first developed by Kissener in 1937 in Holland and applied it in the treatment plants in Holland. So, however, other sources reported that it was Gold, Gold, who pioneered the process by incorporating the system at the Tolmans Island plant in New York City in 1939. So kung ganon, baka si Kisner nga talaga noon na dahil earlier siya ng 2 years na implement na niya ito, di ba? Now, we move on. Ano ba ang modification na ito all about? What is the purpose of this modification? So, step feed aeration is a modification of a conventional activated sludge process that gives solution sa pagkulang ng oxygen requirements in the conventional tank. Ano ba ibig sabihin nito? So, let's compare it. In conventional kasi, pagpasok ng primary effluent aeration tank, nag-cause ito ng very high load of BOD sa inlet. Tapos ang nangyayari, mas nagiging mataas pa ang concentration ng oxygen demand kaysa sa oxygen, which is ayaw natin. Ito nga no, ang graph na nagre-represent ng BOD at oxygen supplied along the tank. Makikita natin dito na ang oxygen demand ay mas mataas pa sa oxygen supplied at the inlet, which is ayaw natin. Kaya ating ating minomodify para maagapan ang problema na ito. At ito nga ay ang step feed aeration. Now, step feed aeration process is used to provide a more uniform distribution of oxygen demand throughout the aeration tank. How? The modification is relatively simple concept. It is implemented by feeding the primary effluent to two or more locations along the flow of the path of mixed liquor as it travels from head to the end of the aeration tank. So, in conventional, ito nga, no, ikita natin na ang primary effluent ay ini-introduce sa ating aeration tank at two or more locations. Kaya, nangyayari na didistribute na ang BOD content sa kanyang inlet. Mababawasan na ang BOD concentration at every entry na magsasatisfy na ito sa ating oxygen supply. Na ito ang mangyayari kung titingnan natin ang oxygen demand. No. So in conventional tank, return sludge is returned entirely to the head of the aeration tank. While in this modification, the organic load or the BOD is distributed uniformly. Dahilan na na-reduce ang oxygen demand at the head of the aeration tank. Yan nga, no? Now, ito ang mangyayari kung titingnan natin ang oxygen demand at oxygen supply along the tank. Dahil hindi man nagbabago hindi man natin binago kung paano natin ini-introduce ang oxygen supply kaya along the tank is constant lang ito. Pero ang ating BOD ay nagba-vary in a spiking pattern along the tank length. At each location where the primary effluent is introduced into the aeration tank, the BOD spikes up, then gradually declines until it spikes up again at the next point of the primary effluent entry. Now we move on to its advantages. First, the BOD distribution is uniform, which means efficient aerating of the wastewater because the oxygen supply along the tank is much more sufficient than the BOD at every point of entry. The percent of the primary effluent distributed to each location can be varied to optimize and process performance. And also, it equalizes the food to microorganism ratio. Thus, it lowers the peak oxygen demand. Yun nga, no? Makikita natin sa graph na ito na ang kanyang peak oxygen demand ay nasustentuhan na ng ating oxygen supply. Now, the disadvantages is, on the downside, this modification requires a large aeration tank capacity, which means that if you enlarge the tank capacity, it is higher in construction costs, and also it is very sensitive to operation problems. Now here is the design parameters of this depth feed. Ito nga palang table na ito ay kinuha ko lang din sa kay David L. Russell ba yun sa practical wastewater treatment. So, yun na nga. Ang step ration is flow regime niya is plug flow or plug flow reactor, which means na ang kanyang BOD at the inlet is maximum. At ang kanyang MLSS or mixed liquor suspended solids is from the range of 2,000 to 3,500 milligrams per liter. Ang ratio niya sa kanyang mixed liquor volatile suspended solids to mixed liquor suspended solids is 0.8. At ang detention time ng step aeration is around 3 to 5 hours. Yan nga, no? At ito ang return sludge ratio na naglalaro sa range na 0.25 to 0.75. At ang kanyang BOD removal percentage is around 85 to 95%. Okay? So, now, next is the tapered aeration. Now, the flow pattern of this modification is just the same as the conventional ASP, which is from head to end. So the difference is only how we supply the oxygen within the tank as the mixed liquor travels along the length of the tank. Nakita natin kanina na sa conventional ASP, ang BOD at the start of the tank ay mataas. At habang nagta-travel ang wastewater along the tank, pababa din ng pababa ang BOD. Kaya ang ginawa sa modification na ito ay sinupply ang air corresponding to the demand. Kung mataas ang BOD sa inlet, mataas din ang supply na oxygen dito sa pamamagitan ng air diffusers. So the difference consists of an adjustments of the air diffusers. So the diffusers are close together at the inlet where more oxygen is needed. Ito nga, no? And towards the end of the aeration basin, the spacing of the diffusers are increased. We provide a high amount of air near the inlet for the reason that it helps the microorganisms grow more rapidly to match the BOD concentration at the inlet. So, and the more the effluent traverses along the tank until it reaches the outlet, the BOD concentration gets smaller and smaller, since we provide a low amount of air that matches this BOD concentration. Okay, this is also called controlled aeration. If samples are collected at various points in the aeration units, it will be found that the BOD of the mixed liquor is not uniform throughout. It is maximum near the inlet and minimum near the outlet. Due to this reason, if the diffused air is applied at a uniform rate, it means that it cannot be utilized properly. So, if, for example, if the distribution compressed air is done in proportion to BOD, for example, it should be like kunwari 40% near the inlet, 25% near the central portion, and 20% near the outlet portion, and remaining 15% is in this large reaction tank if it is provided. So if the diffused air is applied at such a changing rate, it will be called tapered aeration. Now, by tapered aeration, the efficiency of the aeration unit will be increased and it will also result in the overall economy. So ito na nga, no, makikita natin sa conventional ASP, itong mga diffusers are ini-introduce uniformly. Kumbaga, at every point of the tank ay same same intensity lang ang kanyang ini-introduce. No? Credits nga pala sa website na ito dahil sa kanila ko kinuha ang GIF na ito. At Ito ang nangyayari sa tapered aeration. Now, near the inlet, makikita natin na kinukumpul-kumpul ang ating air diffusers dito. Kaya mas malaki ang intensity ng air supply sa near the inlet, and the more it travels along the tank of the the length of the tank ay nag-i-increase din ang spacing ng kanyang diffusers. Meron akong nakita na-research ko rin na ang ginawa dito ay at every third points nila binabago ang diffusers spacing. Kunwari, sa L over 3, meron siyang bali 5. Tapos dito meron siyang sa next is meron siyang 4. At ang sa last ay meron siyang 3. So, ganon. Ganon ang ginawa. Now, we move on to its advantages. Advantages. Due to reduced oxygenation, less air is required, which results in reducing the size of the compressors. Okay? Yun nga, no? Kung ang ating diffusers are ating inoptimize at inutilize talaga natin ang ating oxygen supply with respect to the oxygen demand, mangyayari ay marireduce din ang ating size of the compressors. Which means kung marireduce natin ang size ng compressors, it will affect also the economy in terms of initial and operating cost. Also, avoidance of over-aeration. Mangyayari kasi kung sa conventional ay constant lang ang kanyang nakikita natin kanina guys, di ba? Sa conventional, constant lang ang kanyang oxygen supply throughout the tank. Pero ang mangyayari kasi sa BOD, pag meron na siya near the outlet or in the middle, ang nangyayari kasi ay habang ang ating oxygen supply ay constant, pababa din ng pababa ang ating oxygen demand, no? Ang nangyayari ay hindi na siya parang ganon ka-practical, di ba? Kaya ang difference ng oxygen supply at ang ating oxygen demand ay mataas. Kaya nangyayari ang over-aeration na, and it also prevents growth of nitrifying organisms which may cause high oxygen demand. Okay? Next is the disadvantage. It is, of course, sensitive to operational problems. Kunwari, kung at L over 3 may nasira na isa or dalawa. So, ang nangyayari, hindi na ma-maximize ang ating oxygen supply. Kumbaga, kung ano talaga ang kung how it should work, hindi na ito ganoon nag-work. So, kung magka-problema ay yun na, ang disadvantage. Now, and also, it requires primary treatment. Kasi, meron kasing ibang modification na hindi na nagre-require ng primary treatment. At siguro, i-discuss yan ng ating mga kaklase later on sa kanilang report. Now, last, we have the tapered aeration design parameters. Okay, it is also a plug flow reactor. And also, the mixed liquor suspended solids is around 1,500 to 3,000 in milligrams per liter. And the detention time of tapered aeration is 4 to 8 hours. And the BOD removal is still 85 to 95%. Okay, so step feed and tapered aeration, both of these modification is a plug flow reactor type, which means that the BOD at the inlet is the maximum. Okay, so that's all for my topic. Here is my references, and thank you. Good evening to all. That's all. Thank you, sir. Thank you, classmates.